So we're looking at some more problems out of section 4.3. We're going to look at questions 28, 31, and 40. So question 28. It's asking us to evaluate the trigonometric expression without using a calculator, and it wants us to draw a reference triangle. So it's looking for us to draw a picture. So we want to figure out the cosecant of 3 pi over 4 radians. So the first thing that might be helpful is it might be helpful to figure out 3 pi over 4, how big of an angle is that? So it might be at this point that we don't know exactly where 3 pi over 4 falls in the coordinate plane, an angle of 3 pi over 4 radians. So let's convert that to degrees. So that'll be 3 times 180 degrees divided by 4, because I'm just substituting 180 degrees in for pi radians. Turns out that's 135 degrees. So I'm looking for the cosecant of 135 degrees. So let's draw a picture. So 135 degrees will make my triangle in quadrant 2. Now, if theta is 135 degrees, I need to find the reference angle, which is the angle that sits on the inside of the triangle. That's actually going to be 45 degrees. The reference angle is important because it's going to let me know if I have a 45-45-90 triangle, a 30-60-90 triangle, or maybe I have neither of those two triangles. Maybe I just wind up with a triangle that is not a special triangle. That definitely could be the case. Now I know that that inside angle, that reference angle, is 45 degrees because 45 plus 135 gives me 180. Completes that straight line angle. So I'm going to label the sides here. So the side lengths are going to be 1 root 2. But now I got to be careful here because this point right here, the coordinate of that point would be -1, 1. I need to make that x value negative because to get to that point, the tip of the triangle, from the origin, I had to go left and then up. So my x value is going to be negative because the point is in quadrant 2. Now I just need to have to evaluate the cosecant. Cosecant is hypotenuse over opposite. So it would be root 2 over 1 or just root 2. Let's look at 31. (31) wants me to find the tan of -15 pi over 4. So again, -15 pi over 4. I better convert that into degrees. So I'll do -15 times 180 degrees divided by 4. I get, that's -675 degrees. Now, I want to draw a picture where my theta is -675 degrees. But to make this easier, I'm going to add 360 to that amount a couple of times until I get a positive angle. So I added 360 twice. And it turns out that -675 degrees, that's the same thing as just 45 degrees. That's going to be, it's way easier for me to visualize the positive angle. So all I did was I just added 360 to -675 until I wound up with an angle between 0 and 360. And I'll use that angle. So 45 degrees puts me right in quadrant 1. Makes a nice triangle with all 3 sides being positive. And I'm asked to find the tangent, so that's opposite over adjacent, y over x, 1 over 1, which is just 1. Now let's look at question 40. Question 40 wants me to find the sine, cosine, and tangent for the given theta. So my theta is 11 pi over 2. So my goal is to find the sine of 11 pi over 2, the cosine of 11 pi over 2, and the tangent of 11 pi over 2. That's my goal. So again, first thing I'm going to do is I'm going to convert that into degrees here. So I have pi over 2 is just 90, so I'm doing 90 11 times, which gives me 990. But again, I'm just going to keep subtracting off multiples of 360 until I get something nice. Oh, that looks like it's 270 degrees. I just subtracted off 360 from 990 twice to get 270. I know exactly where 270 is. So you can see I'm really only good at visualizing angles if I know what the angle is between 0 and 360 degrees. So anything I get that's bigger than 360, I just kind of either add 360 or subtract 360 until I can find a coterminal angle that's gonna be easy for me to graph. So 270 falls right down here. Here's 270 degrees. I'll mark off that point. I'll make that point 0, -1. Okay, and I'm going to write out the information that I'm going to need, which is going to be my x value is 0, my y value is -1, and the r value, the distance to the origin, is 1. So notice this is one of those scenarios where I can figure out the x and the y value from looking at the coordinate. The r value is always positive. It's the distance from the point to the origin. So notice I'm doing this without having a triangle. Whenever my point falls on the axes, I don't end up with a triangle, but I can still evaluate my trig functions because I can figure out the x value, the y value, and the r value. So sine, that's opposite over hypotenuse. That's y over r. So in this case, it is going to be -1 over 1, which is -1. Cosine of 11 pi over 2, that's going to be x over r, which is 0 over 1, which is 0. And the tangent of 11 pi over 2, that's y over x, opposite over adjacent. That's -1 over 0, and that is undefined. So we have finished those 3 problems.